I welcome you all to this physics class. I am Dr. Sumit Bhatnagar, physics teacher at Prepaze. So before starting this topic, I'll just briefly explain you what is Prepaze. And Prepaze is basically an online platform where students can take online sessions in groups, one-to-one also. And you can take sessions whenever you want. We have dedicated teachers from all over the world, so whichever time suits you, you can take tuitions from teachers, help yourself to clarify your doubts, understand at your own pace, at your home comfort of your house. All right, start today's class. So today we'll be discussing the very first topic in physics, which is kinematics. Now, this topic is I would say, is the basic foundation for mechanics. For a lot of different concepts can be used from this, and which can be used in future chapters in physics. All right. Now, what is kinematics? Kinematics is basically is a study of motion of object. Is the study of motion of objects. All right, objects or particles. So this is basically we study about this motion. So there are different physical quantities which we need to study first to understand motion better. The first thing over here, it is basically the concept of distance and displacement. All right, distance and displacement. All right. So what is distance? Distance basically is the total path length. It's the total path traveled by an object. All right. Now it's a scalar quantity. Scalar quantity means what? It's basically a quantity where we use only the magnitude. We are interested only in the magnitude and not the direction of that. So, and the SI unit of it, if you talk, SI unit is basically meters. How to understand it? Suppose I consider a point, let's say a point A. Now there is a particle which starts from point A and goes to a point B. And then from A, initially goes from A to B, the particle or the object. And then from B, it goes perpendicularly straight up to the point C. So suppose AB distance, I say it's 5 meters, BC distance, I say it's 5 meters. So what is the distance traveled? Simply the answer of yours will be 10 meters, isn't it? Right. So the distance is basically 10 meters because it's the total path traveled, that is AB plus BC. Now that was about the distance. Now try to understand displacement. So these two terms come all together. Now the displacement is basically a vector quantity. We have already studied about a scalar quantity where we are discussing the magnitude only. Now vector quantity is basically we study the both magnitude and the direction. All right. SI unit will remain the same. It is meters. So what is displacement now? It is the change in position. We can say that change in position of an object, change in position of an object, or it is the shortest path. Another definition is shortest path connecting initial and final position. And final position. That means what? Let us try to understand with the same example which I gave you earlier. So I told you that the object was traveling from A, started from A, then it went to B, 5 meters, then it went straight up to the point C. This is 5 meters, this is 5 meters. Now, what is displacement? See the definition carefully. It is the shortest path connecting the initial and final position. What is the initial position? It is A. What is the final position? It is C. So what is the shortest path? It is a straight line connecting between these two, which is basically AC. And you can see it is a right angle triangle. So you can use Pythagoras theorem, all right, to find it, the distance. It is basically 5 root 2 meters. Clear? Right? Under root of B square plus BC square will give you AC square. That is basically 5 root 2 meters. So what is the displacement over here? It is 5 root 2 meters. So we will say that the displacement is 5 root 2 meters. And using this, basically, since displacement, we said that it's a vector quantity, right? We have to use both magnitude and direction. We have told already the magnitude. But what is the direction? Direction for this case, we can see that it is AC vector, like this, towards AC. Or I can also write like that. Suppose the angle made with AB is theta. So what I can say, the direction is tan theta is equal to BC over AB, or theta is equal to what? Over here is 45 degrees. Okay, with AB. That's also, you can say that in this case. So both are depending on what the question is asking. You have to find the angle theta or which path along which it has traveled. Now displacement is represented by another letter called x. Sometimes it is x we can represent, or sometimes it's s also. Both these letters are used to represent displacement. All right. So that was about distance and displacement. Now let me give you one quick example which will distinguish them clearly, and it will help you to understand what exactly this two together means. So you will never forget. Let's discuss an example on this. Let's say this is a home of a student. Student is there. Both school and school are shown in the figure. So suppose let's say there are two paths a student can take. This is a straight path connecting. This is a straight path. So I will say it's a straight path. And let me call this path 1. And the distance of this is, the total length of this is 75 meters. All right. Now there is another path which is a curve path like this. Curve path. Student now, suppose this is part 2. I will say it is 100 meters. Obviously it will be higher, greater. Like these two paths are there I mentioned. Now imagine I give you one question that if student goes from home to school along path 2, suppose along path 2, then what is the distance? Your answer simply will be what? The total path traveled, it is 100 meters. That's correct. And what is the displacement? Now, most of the student over here says 100 meters, but it is not 100 meters. It is only 75 meters. Why? Because the definition of displacement was the shortest path connecting initial and final position. And what is the shortest path over here? It's a straight line path. All right. It is only 75 meters. Again, if I ask you another thing, if a student goes from home to school along path 2 only, along path 2, all right, and he returns back now from school to home along path 1. If I ask again the question, what is the distance traveled? You will simply say it is 100 plus 75, which is 175 meters. That is perfectly correct. What is the displacement? Now, a lot of students say that it is 150 meters. Okay, because seeing this example over here, they say that from home to school is 75, from school to home is again 75, but it is not 150 meters, it is simply zero. Why? Because now the particle or the object has come back to its original position. What was the definition if you see from the displacement? It was the distance between the initial and final position. Okay, if the initial and the final position is same, right now in this case is home, that means what is the distance? What is the path length? It is just zero. Okay, that is particle has not even traveled. So that is the meaning of displacement in physics. If the initial and final position are same, that means the displacement will be zero. All right. So hope this examples clearly makes you understand what exactly distance and displacement means. Now let's move further. Now speed and the velocity concept we'll be doing now. Now what is speed? Okay, let's study that first. Speed is basically we say it's a total distance, or rather than total distance, I will just say it is a distance. It is basically the distance traveled over time. Now distance traveled was measured in meters and time isn't measured in seconds. So what is the SI unit of this? It is meter per second. And since distance is a scalar quantity, speed is also a scalar quantity. That is, we are only interested in the magnitude and not the direction that where the particle is going. Only the magnitude is sufficient enough to describe the speed of the particle. Another term comes over here is the average speed. Now, average speed is basically what? It is a total distance traveled by a particle over the total time taken. This is in meters. Again, obviously the unit and everything will be same only. Speed, just the basic distinguishing between both means the same, but basic thing is that speed, whenever we say speed, basically we means at a particular instant. Suppose that there's a train traveling or a car moving. Okay, we say what is the speed? So what we see is the speedometer, right? We see the speedometer, suppose it's 52 kilometers per hour. We say its speed is 52 kilometers per hour. But now if I talk about average speed, basically I talk about the total motion, like from where to where the particle has traveled. That is the total distance and divide by total time. There we use average speed over. So more this concept is used more, basically average speed. Let me give you one example and this will help you to understand. Suppose if I give you a question or a particle or object goes from position A to B with speed s1 in time t1, goes from position B to position C with speed s2 in time t2. Question is then what is its average speed? So if you are watching this lecture, I will suggest please stop, pause this video and do it by yourself and then come back to check your answer. Okay, I will tell you the answer. So what we have to do over here, we know the formula of average speed is total distance over total time. So first thing is basically suppose this is A position, this is B position and this is C position, let's say. Now from A to B the particle is traveling with the speed v1 and in time t1 it completes it. From B to C, it's traveling with V2. In time T2, it completes it. So what is the distance from A to B? So the distance A to B will be what? Go by the formula. Distance is what? Speed into time. So V1 into T1. That is a distance. What is distance B to C? It is V2 into T2. All right, that is basically the distance. So what is the total distance? Total distance A to C is what? V1 T1 plus V2 T2. All right, that is a total distance. And what is the total time taken? Total time taken is what? Time taken from A to C is what? It's T1 plus T2. That means what is the average speed now? Average speed will become now total distance, which is V1 T1 plus V2 T2 over T1 plus T2. That is the average speed. So this is how basically we find the average speed. There are a lot of more questions which can be framed, and a lot of questions are basically asked from this basic concept. Now the next thing which comes in this about is what the velocity. So now what is velocity now? Velocity is basically now it is the displacement over time. All right, that is formula of the velocity and the definition of that. Now, displacement obviously was meters, time was in seconds. The velocity, the unit will remain the same, meter per second, and it is a vector quantity because displacement was our vector quantity. All right, so this was a definition of velocity. Now, there is another term which is quite popularly used in velocity concept is the instantaneous velocity. Instantaneous velocity. Now, what is the instantaneous velocity? Instantaneous velocity, as the word is itself suggesting, it is velocity at a particular time or moment is much better term. At a particular moment, what is the velocity? If I say you that a car is traveling or a train is traveling with some velocity, then what is the velocity at a particular time? So basically you are describing this is instantaneous velocity. That is the meaning of it. Now how it is more useful, basically we have to see the graph. We will come to graphs of the motion later on in this chapter, but for understanding instantaneous velocity, let me give you one quick example. So suppose there is a VT graph, and the VT graphs look like this, a straight line. If I ask you at time t1, what is the velocity? What you will do is simply plot it like this, extend the lines. This value is the instantaneous velocity. This value over here is the instantaneous velocity, and that's will be your answer. But if it is a ST graph, that is ST or X, that is a displacement time graph, and it looks something like this. We will study this graph. Basically, both of the graphs mean the same thing. We will study them later on. So suppose if I ask what is the velocity at time t1 now, what you will do? You will extend it, and then at that point basically you will draw a tangent line. This tangent or the slope, tangent we say, or the slope gives us what? Instantaneous velocity. It's the instantaneous velocity with basically the particle is moving at that point, the slope. So we have to find the slope and then proceed to forget the answer. So how to find the slope? Basically this is, if I plot it, let's say this is delta s and this is what delta t. So the velocity or the instantaneous velocity will be delta s over delta t. That is a change during this time. More mathematically, we say it is ds by dt also. Delta is basically used for a large change and ds is a small change. So the smaller we are going, more appropriate we are or more closer to the answer. So that's why more appropriately we use ds by dt, but they use delta s or delta t instead of ds because some students have not taken mathematics. So that's why to remove the confusion, they just take delta instead of d. So finding the slope and then it gives you instantaneous velocity. How will you find the slope? If the graph is given, simply by your ruler, just plot it, and at that point basically you have to find the slope. So and find the angle of theta. So they will give the slope. Continue from this topic in the next class of ours. Please join, try and take a free trial at Prepaze. There are a lot of experienced tutors like me. Do check the website and take a free trial the earliest. All right. Okay, then see you then. Bye.